Hello, this is the luckiest maths teacher in the world. Today we look at the area of a trapezium and of a kite, and we're going to find the area of both of these using a formula. So firstly, let's look at a trapezium. So remember, a trapezium is a quadrilateral of four-sided shape that looks a bit like this. It has one pair of parallel sides. So these two sides, top and bottom, are parallel. So I'm just going to call them A and B, and we need to know the perpendicular height for this as well. So again, H means perpendicular height, not slant height. So the area of a trapezium, so that's the big A for area, is half times the perpendicular height times the sum of the two parallel sides, right? So let's go ahead and do an example of this. So let's have this trapezium here. So it's a trapezium because it's a four-sided shape, and this one has only one pair of parallel sides. So the area of this shape will be a half times the perpendicular height. So remember, we don't want the slant height. 13 is the slant height, but the perpendicular height is 12, and then we multiply that by the sum of the two parallel sides. So we actually don't need 13 at all to find the area of a trapezium. We don't need the slant height. We would need it for the perimeter, but not for the area. So half times 12, remember that just equals 6, half of 12. 6 times, and we do the brackets first, so it'll be 6 times 54, which is 324, and if no units are given, we just write u squared for units squared. So that's how we find the area of a trapezium. Now let's look at a kite. So now we're looking at the area of a kite. So remember, a kite is a quadrilateral of four-sided shape, but adjacent sides next to each other are equal, unlike a parallelogram where opposite sides are equal. So this particular kite has no parallel sides. If it does have two pairs of parallel sides, then it's a rhombus. A rhombus is a special type of kite where all sides are equal. So if you need to find the area of a rhombus, you just treat it like we're going to treat this one here. You find the area of the kite. Now note that we can divide this shape into two isosceles triangles. So they're isosceles because they have two sides equal. So if we look at this first triangle here, it's isosceles because this side and this side are equal to each other. So let's call the base x, and we'll call the perpendicular height y. So the area of this blue triangle will be base times perpendicular height on 2. Now let's look at this bottom triangle, which is also an isosceles triangle. Again, the line that we draw from the top to the bottom bisects the base perpendicularly. We know that because it's an isosceles triangle. So let's call this perpendicular height z, and the base is again x. So the area of that triangle is x times z, base times height, divided by 2. So the area of the whole kite is just these two added together, which is x, y on 2 plus x times z on 2. Now this is exactly the same as if we take out x over 2 and then we put in y plus z. So if you expand this using the distributive law, you'll just get that up there. But what you notice is that x is one of the diagonals and y plus z is another diagonal. Y plus z is this whole line here. So what we have is the area of a kite is the first diagonal times the second diagonal, so this was x, and this was the whole line y plus z, divided by 2. So the area of a kite is just the product of both diagonals divided by 2. So let's look at an example. So now we're going to look at finding the area of this shape here. So the fact that all sides are equal doesn't matter too much. This shape is still a kite because there are two pairs of sides that are adjacent and equal. It just happens that all the sides are equal. So when we're finding the area of a rhombus, we just take the two diagonals, multiply them together, and divide our answer by 2. So in this case, it would be 320 centimeters squared. Now, I should just point out that you could actually use this if you were calculating the area of a square. It's just that in the square, the two diagonals are the same length as each other. So we could use this if we want to find the area of a square when we knew the diagonals, but we didn't know the length of each side as we do here. But for the area of any kite, just multiply the two diagonals together, divide by 2, you've got your answer. How easy is that? Hope you have a good day. This has been the luckiest maths teacher in the world. Have a wonderful, wonderful time learning more about area.